understanding. And as a further step, what we are trying to do in the case of the safety project, so the one of doctor, more like to develop this method even for other cases. So, for example, for regression, because what we have until now can work for classification but not for regression. And in any case, we are also going ahead with these other two projects, trying to develop more for also looking at more realistic setting. So that's all.
Thank you very much. Thank you very much. Next is Marine Picot from Centrale Supélec.
Hi everyone, I'm a PhD student in L2S, Laboratoire des Systèmes in Centrale Supélec, and in a co-title with McGill University in Montreal, Canada. And my work is also focused on improving the security of neural network. So actually, it's fairly easy to attack a deep neural network. One of the ways to attack it is through what we call adversarial examples. So it's very small additive noise that we're going to add to the inputs in order to fool the classifier. So a very common example is this one. So we have a photo of a panda, and the model is actually classifying it as a panda with a confidence of around 50%. And when we add this patch with an amplitude that is very small compared to the first amplitude, we have now an image that is still a panda, but the model thinks it's a given, so a small monkey. And this time it's very confident in its mistake. It's extremely important to actually have security in neural networks, for two main fields, and most critical applications. So the first one is security, and the second one is safety, because it has been proven that it was possible to actually transfer the adversarial example to the real world. Can we? How to defend against those adversarial examples? There's two main ways. The first one is what we call robustness. So we are going to try to train a new classifier that is going to rightfully classify the example, even in the presence of the perturbation. And the second way is through detection. So we are going to use statistical analysis on the image and on the model in order to extract features that are going to allow us to determine if it's clean or attacked. In both cases, we developed tools based on statistics in order to improve the state of the art. Thank you.
Thank you. Next, sorry again from Xijing Zhang, more or less, from ENS Paris-Saclay.
Yes, 50 years ago, I was studying Jiangbong's class on computer vision. So I'm very glad to present my research activities at NET in Toulouse and also scientific collaborations that we'd like to develop. NET is a Toulouse institute dedicated to AI for research and education. There are two key application sectors, which are transport and robotics, with more than 50 partners. There are more than 200 researchers, 3 integrative programs, and 24 scientific chairs, with three research axes that are acceptable AI, certifiable AI, and collaborative AI. My research activities fall into the first two axes with 2 directions. One is to understand machine learning models for classification and regression problems with complex data. The idea is to build models of data so as to characterize intrinsic structures of data that are learned in deep learning models. Another direction is to apply machine learning to data assimilation. Data assimilation is an inverse problem like image denoising in signal processing. And the idea here is to combine physical models developed in data assimilation with deep learning models so as to improve the state of the art. In all these directions, we also study optimization and game algorithms in order to solve a problem. Next page. And there are we'd like to develop scientific collaboration with both industry and academy. after COVID, Toulouse wants to move beyond the transport and the robotics. In particular, we'd like to work with people in health and environment. Also, we'd like to study deep learning or image or time series analysis and modeling. So one topic would be to study generative models of images in time series. So you can see there are many, they cover a broad range of domains. And the question we want to study is fundamental research in the understanding of the randomness of data. And another topic would be to study data assimilation with recurrent neural networks. The idea is to predict or understand a dynamical system at a future time. And here we can see if we, for a dynamical system which is periodic or chaotic or recurrent, there are underlying knowledge, domain knowledge. So we'd like to work with people who has a good domain knowledge so that we can build machine learning models to impose natural constraints to that important constraint to a model, so as to make the model that's safe to the society. So that's the ambition. Thank you very much for your attention.
Thank you, thank you. Next is Marie Garin from ENS Paris-Saclay. That's okay.
So good afternoon to all of you, and thank you for your attendance. So my name is Marie, and I am a PhD student at the Interdisciplinary Research Center, Centre Borelli, at ENS Paris-Saclay. It's a main hosting institution. So this laboratory is a mixed research unit, bringing together researchers in mathematics, computer science, and neuroscience, and all those researchers are involved in interfaces with biomedical fields and with industrial transfer. We notably work with a network of several hospitals. My research is oriented around two axes. So the first one is privacy-preserving machine learning. So traditionally, in machine learning, data is gathered at a single location. So this widespread architecture faces a lot of constraints. So the crucial one being privacy and latency. So that's why the machine learning community has a search alternative to centralized learning. So one of them is federated learning. So it's new fields of growing emphasis. And so in this field, the main point is that the data are stored locally, and you train the model locally too. So there is two main advantage for this for keeping data locally. So the first one is that it preserves privacy, unapodictic values whose endangerment can entail insidious societal effects such as self-censorship. And the second one is that it enables to collaboratively learn even if data sharing is impracticable or even illegal. And my second axe of research can be reflected by the organization of this seminar. So the Séminaire critique de l'intelligence artificielle, CIA for the little joke. So this seminar is inspired by critical theory as developed by the sociologist Horkheimer and the philosopher Adorno. And this seminar wishes to instill an epistemological reflection about AI at a time when AI seems to be totalizing. So and raising the following questions. So what are the limits of AI? Who and how is produced the knowledge? So notably the data. What in the collective imagination belongs to myth or ideology? What are the power relationships between all the actors? So between research, industry, governments, and what is its social relevance at a time of the ecological stress? And so if you want to attend this seminar, you can do it on Zoom. So yes, okay. Thanks.
Thank you. Next is Louis Escouflair from the Université Catholique de Louvain.
So, hello everyone. My name is Louis Escouflair, and I'm a PhD researcher in computational linguistics at UC Louvain, more specifically at the Media Research Observatory and the Center for NLP at UC Louvain. I'm here to present, to pitch my project, which is called OpiNews, and its main goal is to build an algorithm that would be capable of automatically detecting, measuring and analyzing subjectivity, linguistic subjectivity, in French press articles. So why did we want to start this project? Because we noticed that in a lot of people in Europe, actually around 40% of the European population, gets their information, their daily news, directly from social media, from Facebook, Instagram, Twitter, TikTok. A lot of people get their news articles from there. But the problem is that, of course, these news articles are pushed by recommendation algorithms, and that the articles that we see most are also the ones that will provoke the most emotions to the readers, because that's the one that they want to push forward. And of course, these articles are also the ones that are the most polarizing, the most polarized, and that contain the most subjectivity. We do not want to eradicate opinion from journalism, because there will always be a place for opinion. What we want to do is to help the readers understand when what they're reading is pure fact, or when it's tainted, influenced by the opinion or the point of view of the journalist that wrote the article. There are many applications that are possible with this algorithm. We could help journalists write or correct their articles to make them less subjective. We could also imagine a website that would allow the people to pick an information and see what every media has said about it. If some media are biased towards one position, if other media are biased towards another position, and so help the people to make their own opinion about a news and not just follow one single media's opinion. So, of course, we need data to build such an algorithm. For now, we are working with data from the French Belgian public service media, so RTBF. We already have good results, but it's hard to extend our results to other media or to articles coming from other types of media. And so that's why we're looking if anyone here happens to have access or to have contacts that could help us get data from other French press groups or Belgian French groups, or even from other countries. We're also open to French data or Quebecois data. So yeah, thank you for your attention.
Thank you. The next is Carmen Mazin. I'm sorry.
Don't worry. Good afternoon, everyone. My name is Carmen Mazin. I'm a PhD researcher at VUB, so just around the corner. And I work in an interdisciplinary research group, which is also part of the Data Analytics Laboratory. And we aim to develop human-centered AI. The evolution of AI has been incredible in the past decades. Dimension, speed, vastness was impressive. Yeah, unfortunately, sometimes things go wrong. AI systems do not understand what we mean by human values, and therefore they can create or propagate biases. And that's something that we don't want. We like algorithmic fairness. The bad news first, fairness is a philosophical concept, and each one of us will have a different definition of what that means and how it can be implemented. Secondly, there's no silver bullet. There's no way that you can just flick a switch and everything is solved. And that is because bias creeps into your systems in all of the steps of your development phase. In the data collection, in the training of your model, but also in the application of your model. And in our group, we are looking at how to solve that. And I'd like to present two examples of what we've been doing in the past years. Maybe starting under here, So fairness definitions, there's a lot of them, and there's also trade-offs between them, which is unfortunate. And we developed a tool to visualize this trade-off, and that also helps by seeing in which regions or in which situations this trade-off is minimal. And we've also shown that it is possible, that in some situations it is minimal. And then secondly, on the top here, it also happens a lot that you have a model, but you don't have access to the training data because of whatever reasons. And then you still would like to evaluate if this model is fair or not. And how we do this is by a new technique where we fix the outputs and we ask the model what is the ideal input for that specific output. So which data activates you the most to give us this specific output. And in that way we can evaluate if the model has preferences for certain characteristics of protected features, which we would not like to. And yeah, the image here is a visualization where you could see this model, for example, had a preference for people who were married to a woman, which is not, not half of the population, let's say. Next slide, please. So why am I here? I am very interested in getting to know you, the other young researchers working on these topics. And then I'm also looking for data sets, because the tools that we've developed, we are using at the moment on publicly available data sets, but it would be interesting to see in what happens on real life data sets. So these are my contact details. I look forward to talk to you later.
All right. Next is Lisa Kutsoviti-Kumeri.
Yeah, very good.
Thank you.
Thank you.
From the University of Kassel.
Indeed. Hello, everyone. You can hear me, right? So I am the fourth researcher who is working on fairness and explainable AI. I am doing a PhD at Hasselt University, and I am part of the Business Informatics Research Group. What my research tries to answer is, how do we make sure that features in our data are not biased? Why is this important? Nowadays, companies need to be accountable. They need to explain why they took certain decisions. To give an example, let's say that a bank needs to classify loan applicants in terms of being eligible or not to get this loan. And they use certain attributes for that, say the checking account, their employment. But they might also use some variables like gender. And I think we can all agree that decisions should, like classifying somebody in terms of creditworthiness, should not be based on the gender of somebody. How do we make sure of that? Can we go on? So there are many measures that have been developed for that. Carmen already mentioned some of them. So there are many fairness definitions. Some of them are based on statistics, correlation methods, linear regression, etc. We have created two novel measures that are based on two fundamentally different methods. The first measure uses fuzzy rough sets to measure explicit bias in data. It assigns a certain percentage to a feature in the data, which means this percentage represents the influence of that feature on the classification outcome. For example, if gender gets a very high percentage relative to the other features, then we can say that our data might be biased against gender. So we, of course, compared our measure to baseline approaches, and we found exactly the opposite results, which allowed us to conclude that maybe we are reflecting a new type of bias. The second bias measure measures implicit bias. And to do that, we use fuzzy cognitive maps. Again, this measure assigns, again, a percentage to each feature in the data. And this percentage reflects the influence of all other features on a certain, let's say, biased feature. Fuzzy cognitive maps allow us to measure all interactions within a complex system. And in this way, we account for implicit bias. We have published both these measures on 2 journal papers. but we again use them on publicly available datasets. We would love to test them on real-life datasets, and I would also love to cooperate with researchers also in the field of fairness and maybe encourage them to use our measures and see how we can arrive to some interesting results. My email is here on the slides. I will be happy to share also my LinkedIn profile with you and stay in contact. Thank you.
I think we have our last speaker, Mylène Maignan from École Normale.
So hi to you all. My name is Mylène Maignan. I'm a third year PhD student at the École Normale Supérieure Rue d'Ulm, where I study data science and literature at the same time. Having obtained 2 master's degrees, one in literature, both from Sorbonne University and the other one from King's College London, and another master's degree in digital humanities or in computer science from École Nationale des Chartes in Paris. I then obtained a scholarship to conduct my research in data science and English literature. I'm part of the Lattice Lab, which is a multidisciplinary unit within the École Normale Supérieure, and it gathers a lot of different academics coming from various backgrounds, such as in natural language processing, cognitive linguistics, or digital humanities. My PhD consists in exploring a literary corpus thanks to digital tools. I created a dataset of more than 40,000 theatre reviews, all of them related to the London contemporary drama stage. And very concretely, what I do is I use computational techniques to study English literature. So I might use natural language processing, machine learning, sentiment analysis, digital maps, in order to better understand literary history and theories thanks to numbers and to statistics. I created a website which is called dramacritics.com. So if you're curious and interested in my work, you can visit it. So can I have the second? Yeah, thanks. So my research is almost done, and my PhD defense is due in a couple of months. So I would be eager to find a position as either a product owner or a digital project manager, supervising the creation of databases, managing the backlog, or analyzing and visualizing data, or even actually collaborating with UI or UX designers are very interesting tasks that I would be happy to help with. And my background in computer science, enabled me to have an excellent command of Python, R, and HTML languages, and also, of course, machine learning techniques. And bilingual in English and in French, my studies in literature also helps me develop a sharp knowledge of both languages, which are valuable assets in communication and marketing fields. So if you're looking for someone, there I am. And thank you for your attention.
So thanks to everybody. So it was so short, but we have 15 minutes for questions. So if somebody has a question, please go ahead and ask. If nobody does, I will start. But okay, I will start, and then no, go ahead. Or you can pass this and I will speak.
Actually, it's not really a question, but more to share some information to researchers that are looking for data sets and that are looking to try their models. In my laboratory, we have something that is called iPol, and the goal is to encourage reproducibility in research. And so the idea is that we are organizing what is called ML brief, and the idea is to spend a week together together in order to create some tool to add to this tool for reproducing research. And after this, people can go and use your algorithm to with their data. And with that, after you will have the result of those people using your data. So yeah, just to share these things. But we can speak.
For those of you who don't know IPOL, it's a very nice journal, but mostly about image processing with code, data. It's very, very well done, so useful resource.
Sorry, I forgot the name. It's about federated learning. Yes, right. And collaborative learning. I want to know which information did you share for collaborative learning? Is it a weight matrix, something like that?
Yes, so the idea of federated learning is that you don't share data, so you don't send your data to collaboratively learn, but you will share, for example, it depends actually on the model that you are using. So if each node that are learning together use, for example, a neural network, the thing that you will share with all nodes will be the weight of your neural network. Or, for example, if you do a regression, for example, a ridge regression, the thing that you will share between the nodes will be the parameters that you have estimated. So actually, it depends on the model, but the idea is to share the parameter of the model that you learn locally, and after to aggregate all those parameters.
I think the main objective is to protect privacy. That's it. So I work on distributed learning for speech recognition. And when I analyze the weight matrix, I show that some information like gender was in the weight matrix. So this one is like private information. So did you try to know what is on your weight matrix? Is there some information that was not private?
So I don't know this situation that you're talking to, but it's for me it's strange because if there are one information such as gender, it means that you have shared data, and not the no you're saying that. Okay. Okay. Okay, so you mean that you retrieve the information? Okay, yeah. There is a lot of papers about federated learning, for example, how to backdoor federated learning and how to get information back. And I think that in that case, maybe we will have to speak with Carmen, because you can add some differential privacy in the.
Yeah, it's not actually my topic, but it's a lot of people in my team are working on differential privacy. And so basically, like, for example, you do some training locally, and then you send the gradients on the central part, and then from the gradients, you try to infer information. And so here you have basically the differential privacy where it acts, because basically you have to, in some way, guarantee that you have a maximum amount, how can I say, of not information, but some kind of information that could be retrieved. Basically, it's like a trade-off between privacy and utility. The project I'm doing now, it's not exactly on this field, as it is not really about federated learning and the machine learning, because it's more about I have a database, there are sensitive information inside this database. Okay, you apply differential privacy, that it's a known topic, but you have basically what happens that you have some obfuscation mechanism, okay, and from this obfuscation mechanism, so starting from the beginning, you have a database, and you are going to do a query on this database. So you are going to have an answer. Now, if there are some sensitive data inside this database, you do not want to have back as answer the sensitive data, but you want to have something that is obfuscated. So this is what is about differential privacy, basically. So in the project that we are doing is like trying to understand how far, if, for example, we supposed to have this obfuscation mechanism, okay, with the estimator that we are going to create, we want to understand how much far we are going to the reality. It's really, it's a project that I started like 2 months ago, so it's quite new. But in my team, if you are interested, it's a Comete team in IRIA. There are people that are working actually in federated learning and differential privacy applied to machine learning.
It's very interesting, but maybe you guys can talk at the reception. So there is a little bit of time left for the other people. No, it's good if that works, right? So any other question? Otherwise, I have some questions. No? Yes, go ahead. You want to go into the differential?
I have a question for Lisa. I'm also really interested in bias in machine learning, but I think it could be very interesting to use machine learning to analyze bias and stereotypes in corpora for sociological purposes, maybe. And I was curious when you said that the new measure you developed, it kind of analyzed another type of bias than the previous ones. Do you have any hypothesis on what kind of bias and how it differs from the other types of biases?
So I would like, there are 2 points here. The first point is that, the type of bias that we define the type of bias as influence in decision making. So the higher the influence, the more biased, let's say. But this is always relative to the other features in the data. And then you also mentioned machine learning. In our approach, we still do not approach machine learning at all. But this is the next step that we would like to do. So we have the measure, and now using this measure, we would like to pre-process the data using also an optimization method, finding the trade-off between bias removal, accuracy, and computational time. And this will include machine learning, but until now, not. Make sense?
Yeah. Okay. Yeah, any other question? Yeah, I have 2 questions. I'm curious. So one was for Marine Picot. I'm always on this adversarial stuff. I always thought, I don't know anything about it, but I always thought that the worst adversary was nature. Because you have bad people out there, but nature is out there, and it will, and the thing you should optimize for nature is not the same thing as the thing you should optimize for a bad person, because the bad person himself or herself is optimizing against you. So do you have a comment on that?
This is actually the goal of neural networks, of adversarial examples, sorry. It's to find a way to fool the classifier without fooling us. Meaning that as human, we will not notice that something is wrong, but the answer is going to be wrong.
That's an evil adversary, but nature is not trying to.
Yeah, basically we say that, yeah, we have something that is fixed based on images, and we are supposed to have a good classifier that is going to act nicely on nature.
And then a question for you, and I can speak out. When you look at different articles, isn't it true that a lot of them are just variations of each other, that people pick an article from somewhere and then they change a little bit of things, and then they translate the thing, and so there's not that much variability? I don't know, I'm very naive.
No, it's a good point. In media, a lot of press media pick their articles, that get their information from, I'm not sure how you'd call it in English, but the dépêche, in Belgium you have Belga, AFP, Reuters, but usually the common thing is to modify them a little bit, to just not do copy-paste. And then you also have original content from published by media. For example, the corpus I work with is composed at 40% of original content and 60% of just content picked from these dépêche, these groups. And you also have media that are really trying to trick you. If you look at Russia Today, for example, I mean, I say tricked, but it's clear that they're a lot more biased towards one position than other media. And sometimes you're going to read a news article without even knowing where it comes from, and you don't know that it's biased. You think that everything they say is just fact, but it's actually opinion. And sometimes it's just a matter of a few words or punctuation signs and things like that that can totally change the vibe of an article. So yeah, many articles look the same, but I think that deeply there are some things that are changed. No, we're focusing right now on purely written data. Yeah, it could be interesting. Maybe for after the PhD. Yeah.
And a quick question back to Louis. I understood that you wanted to include also opinions of people, right? No, it wasn't. Journalists. So you would involve experts somehow in your process or not?
There's going to be an annotation process, but carried by journalism students who will review the articles and pick the words or the symbols that they think induce the most subjectivity. But we're not going to ask journalists themselves for this purpose.
Thank you.
Any other questions? Yes?
Time for one more question.
One more, then
Okay.
we can continue the
Yeah, sure. It's looking for you actually. From my point of view, I have the feeling that for me, every position is objectivity doesn't exist, and so my question was. I think it's not like subjective or objective, and it's more like a note. But do you take in account, for example, the fact that even if it's just facts, but which facts are selected, and yeah.
Yeah, it's also a really interesting question. In journalism, it's mostly accepted that subjectivity doesn't exist, but that journalists have to use what they call an objectivity mask and to transform their text to look as objective as possible, as factual as possible. And the second part of your question, so yeah, there's a specter that doesn't rank from objective to subjective, but that rather ranks from all different kinds of opinions around one subject, and that's rather what we want to find the different positions that can be expressed on one subject. And about the selection process, yeah, that's really difficult because it happens outside of the text itself. It also involves citations, who you're going to quote, who you're not going to quote, what position you're going to cite or not in the article. And that's really hard to measure because you would have to compare with other articles on the subject. But that's also something we would like to do. Maybe using text summarization as well. That would be nice.
And there's one last session in the auditorium on French and Belgian ecosystems.